goes to the next slice until you meet to the last point here as a 2 centimeter also. Okay, the next important part is that our calculations on the A. A is the area of the slice. Okay, the area of the slice from slice number 1, slice number 2, 3, 4, 5, and 6. We might say that we're going to use the trapezoidal area. The trapezoidal for area is a half times P times H1 plus H2. As I said again in the last class, H1 and H2 is measured on the left and right sides of the vertical slice. Okay, let us take for the slice number 1 here. The H1 is equal to 0 because it is started here. Okay, for H2, you can measure from the beginning of the vertical height of this of the side of slice 1 until to the base of the slice 1 or at the circular arc. And you can calculate it such as half times with a 2 times with a 0 plus, let's say we assume as a 1. So this is the area for slice number 1. Same goes to slice number 2 until you calculated for slice number 6. And then the next important part is the W. Where is the W? Where is the W? The W is located at the mid of the slice width. Okay, for example here, if you consider all the slices in trapezoidal shape, this is the trapezoidal. So let us take the centroid of this shape. We can have that the W is acting at the half from the B. Okay, this is the half of the P. This is also half to the B. So this is the positions of the W. If you consider all slices in trapezoidal, so the W must be at half from the P. So this is W1, same goes to the here, W2, W3, W4, W5, and lastly is a W6. Okay, if you remember, there are few inputs parameters need to be found. First is B, H1, H2, and then we have the area, we have the W, we have the alpha, we have the disturbance force, and we have the restoring or resistant force. The N is equal to the W cos alpha, and the T is a W sin alpha. Okay, B I have explained, same goes to H, A, and W is a unit weight times with the area. Okay, what is the alpha? Alpha is the interslice angle that you measure from O to the W. Alpha need to be taken seriously on the sign if you have the positive alpha. So the meaning that the W is located on the right sides of the O. Okay, this is how we get the alpha. So the alpha here is a positive. If you have the W is located at the right sides, at the left sides of O, so this is our alpha. Alpha needs to be calculated as a negative. After you have done or you have determined all these input parameters, please ensure you are using the appropriate formula to calculate factor of safety. Remember, the factor of safety or whatever method of analyzing analysis you are using, you have to check whether you are analyzing for ESA or you are analyzed for TSA. The E is the effective stress analysis. T is the total stress analysis, where E you can measure the pore water pressure is not equal to 0, and the T total stress analysis where the pore water pressure is 0. You assume or during this time is a very little drainage to occur. Okay, the relations about ESA and the TSA is on the formula calculations. So please make sure that you are using the right one, such as if you are calculating for ESA, the C prime R theta plus tangent phi summation N over summation T. Okay, for ESA. Kalau kata TSA, so you need to check back lah what's the formula between the disturbance, between the restoring moment to the disturbance moment. Don't forget about the restoring moment can be found from the slip circle of the art here, where it is coming from the CU or C theta. or C, L. L is a theta. So the theta must be calculated in the radian, which is, if you have the theta is equal to 50 degrees, so 50 over 180 times with the pi. Why I have to mention this, because I have seen few students did a mistake on the calculations of the theta. I mean that you are copying from other answers, your friend's answer, but then you do not know what you are having on the formula. And one more thing is that if you have the FOS is more than 1, so we can say that the factor of safety is indicate for stable slope. If you have FOS less than 1, so this is unstable slope. However, if you calculate the FOS to the maximum, such as 100.0 and then 200.0, the factor of safety, is it possible for you to get the answer? This is wrong, totally wrong, because factor of safety mostly around designated for between maximum is a 2.5. You look at to the previous introductions of the slope stability, I have mentioned the guideline how to indicate or to check whether your calculation FOS is correct or not. So it is mentioned to you if you have a building, so this is the value recommended FOS 2.5. If you get the FOS 100 something or 200 or whatever 150, there's a wrong in your calculations. So it's very what we call it illogical answer to have that once. So please be smart when you are doing analysis, because in the future you're becoming somebody. No matter what's projects you are involved in, you're involved with, if you're not becoming a engineer such as civil or geotechnical, you will be somebody. So you have to use your mind to think, is it logic to have this thing, to have this to have that things? So whatever answer, whatever decision you made, you have to think, or you have to responsible with what you have written. So again, please be prepared for the next Friday on assessment assignment 1. So I think that this is a very good I mean that to refresh with whether you are analyzing for ESA or TSA using the method of slices. And the method of procedure will be not covered in detail for this semester. So I hope that by having these explanations, this will give you the idea how to answer to the previous calculation. I know not all students participate in the exercise, and then they will take the shortcut solutions by copying from other answer. It's coming from your understanding. If you not develop your understanding on this matter, there will be no one's can help you during the critical time. So I think that's end for my refresh on this topic. So the next one, we will be back to our class on the slope stability protections and repairing works. So let us go to the subtopic 3. Okay, thank you for those who helped me to record these sessions. So now we back to our business on the last part, slope repairing and maintenance work. I think that this is very important for you to have the idea how to repair our slope if you have these kinds of situations with a slope failure. The slope failure is a very catastrophic, and it can cause loss of life and also damage to the structure building. And then if you can see in the previous early slides of my presentation topic 3, I have shown to you in our past history we had the landslide in the Bukit Antarabangsa. We had also the rock falls on the Bukit Lanchans. And if you feel that and if you think about this matter, we can relate the situations with the repairing works, the maintenance, how to repair the slope failure, and how about the cost, the budget, the durations to complete the process of repairing. Okay, as you see here, we have around 20 slides, and the slope protections and maintenance, and then the learning outcomes is my expectations you will be able to describe the slope protections and maintenance. So The next one is same thing. We have only one content here, and we proceed to the next important topic subtopic 3, slope protections. Why do we need to have the slope protections and maintenance? And then when it is necessary to do that? And what are the factors to be considered during the constructions of the slope protections and maintenance work? So the ideally is that due to the slope failures such as landslide and then flow debris, and then we have the rotational slides and translational slides. These are the things that bring to you the measures and also can cause in what we call it a huge amount in repairing work. So before we decide what are the best method to repair our failure, we need to consider few factors such as the weather, the climate, and then the purpose of the repairing work. Is it for road constructions, or is it for slope protections, or is it for the retaining wall near the retaining wall for housing area near in the his slide or his slope. Okay, for example here, if you involving with the repairing work, slope protections and reinforcement, it must be according to the local climate environment, engineering geology, and constructions material, engineering types, or comprehensive measures should be adjusted to ensure stability of high-risk upgrade. So if necessary, slope protective engineering measures should not be cancelled or decreased. So under poor climate and hydrological condition, as for rock slopes or loessy slope with a silt, fine sand, or easy uh, to be panium and pica slab to protect subgrade slide slope along the river. And the slope protection generally doesn't consider lateral pressure of slope stratum, so its demand protective slope should have enough stability. As for high and steep protective structure, when design and construction, safety facilities should be set to be checked and maintained. So this is about what we need to know when we decide to choose the best repairing work. And this is one example involving with the membrane. And then these are listed 7 types of slope protections and maintenance, such as unloading, changing the geometry, buttressing, and then we have the structural stabilizations, we have the improving drainage, slope reinforcement, soil improvement, and the last is the vegetations. So these are the things that I see that, and I believe some of you have seen the work done on site. Okay, on these left figures indicates to you the summary of the 7 types of repairing slope protections and maintenance that I have mentioned just now. For example, here we have a steep slope. What we need to do, you can place a gabion wall, and then you can provide a proper drainage, and then you need to have the friction pile, for example, dealing with the soft clay or soft soil, and then there's a trenching, terracing or benching of the slope. You can see that this is the staged phase of the slope where the excavated in the phase 1, phase 2, phase 3. This is another way unloading and changing geometry of the slope. It's very less amount of cost. And the next one is by using the biostabilization technique, and you can also spray shortly on the slope face. And the last one is using the sheet piling. So at the bottom here indicate to you the purpose of using this method, such as if you are using terracing or benching, so it is making the slope more manageable by overlaying into several smaller and less steep slope reinforced by retaining walls such as friction piles. And then the drainage also need to be provided on the slope face because we allow for water to flow out. And remember, if you have the soil that retain high water, so that is prone to fail. So we try to avoid failure due to the hydrostatic pressure. And other than that, we can use rock bolts, and you also can have the soil nailing when you have some sort of weak soil or the weak rock. So this is where you can have a lot of discontinuities between the rock joints, the bedding planes. So that the best way to use using the rock bolting or the soil nailing. Okay, next on the first method, unloading and changing the geometry. It is a very less cost and very simple. Just only need to excavate using some sort of backhoe, and then we can perform in three ways, such as reduce slope height by excavation at the top of the slope, and then you can flatten the slope angle, and the last one is excavate a bench in upper part of the slope. So this is a very simple process, and until that you decide the project no need a huge amount of money, so we can solve the slope failure by proposing these three methods of work for unloading or changing the geometry of the slope angle. Okay, this is one examples where we have case 1, case 2, case 3 with recommendations angle need to be carried out. And the next one is on the slope protections and maintenance using the steel unloading and changing the geometry. What's the best thing about this method is that when you change the slope angle from steep slope to the gentle slope, it may increase the stabilizations of slope, and the angle is usually supported by grass bonding together with the soil. So this conventional method of angle grading requires some excavations. So this type of method does not require heavy load resistance and naturally stabilize the slope with the creepy grass surface. So as I said again, this very simple job. You just cut the slope, and then lastly you place vegetations on the slope face. The next one is on the buttressing. So the buttressing is a process where you apply or where you construct a shear key along the slope face or at the toe of the slope face. So the purpose is to reinforce the slope from soil movement, and then you can see that this is where you have the over excavated the cut slope, and you replace the overcut portion with a high quality fill, and also you apply the shear key for the area. And this is the figure indicate to you how the process involved with the terracing, and then you get the branches, and then you have the proposed finished grade. So this application can be seen at the road constructions or the road embankment. Okay, the next one is a very common for slope repairing or slope protection using the structural. The structural here, as again, the slope is not on be that natural slope or the main slope. The slope also can be considered at the area of the constructions buildings, such as when you are dealing with the deep excavations. So the deep excavation having also a slope. So the retaining of the retaining from soil movement using the retaining wall, such as sheet pile, or you can also use driven cast pile. So the simplest way, such as on the top figure here, using the gabion wall. So the gabion wall is commonly found near the road area. So it's only having the gravel or boulders into the cage. So we retain the slope using the rock weight. The next, other than structural stabilizations, you can also have the anchoring retaining wall, and this one, when you have these kinds of retaining wall, again, it is very expensive. So this back to the purpose of the project and the budget of the project. If you have amount to construct with high repairing work, so you can opt to this method of structural stabilizations. Okay, besides we have this retaining wall, what need to be done next is the masonry and stone pitching may stabilize the slope to eliminate the failure at the face slope. It also may reduce rainwater infiltration and prevent slope erosions of the slope forming materials, and this method also involves rigid slope surface protection such as shotcrete, masonry and stone pitching, and the shotcrete is applying mortar on the slope surface by certain thickness. This is where you have to apply some sort of shotcrete. Why we spray the shotcrete on the slope face? Because we try to prevent any infiltrations of the water. As I said, when the slope is just fully submerged with the water, there is a prone slope failure. So we try to prevent from happening by providing the proper drainage. Okay, this is in the next one, improving drainage. So the improving drainage can be seen in two ways, such as you have the vertical drain, or you have the dewatering well, and then you also have the horizontal drains. One more thing is that you can also have surface drain and subsurface drain. The surface drain can be found in geometrical methods, which to let surface water flows away from the slope. And for the subsurface flow or the subsurface drain, it is found in the returning structure as weep holes and cut-off drain. So it is to remove water that already exists in ground. So that's why when you have a slope face along the road area, you can have two types of the drains, whether in the vertical or horizontal drain, or you can have the surface drain or subsurface drain. So the subsurface drain is inserting together with the returning wall as a weep holes, and then the surface drain, as you can see, placed on the slope face or at the horizontal surface. So this is the purpose where you allow water to flow out from the building or from the structure of the slope. Okay, this is the condition same again. If you provide the drainage system, the chances of the building outpour water pressures and saturations of the subsoil can be minimized, and this is a very effective method. The drainage system must be maintained, and it is easy to maintain the surface drain, but it's difficult to maintain the subsoil drain. This is true because as you see that the surface drains only drains surface water. So if you have some clog of the dry leaf, you can remove easily. However, if you have the dry leaf inside the weep holes, that's very difficult to take out or to remove from the weep holes. So that's why it is suggested that you have to do frequent or periodical maintenance work just to make sure that the drainage well maintained and well functions to allow water flowing out. Again, when we provide the drainage, that we reduce the hydrostatic pressure. Okay, the next one, using the geogrid and membranes. So this is another type of the slope reinforcements. So this is a byproduct. The advantage of using this slope reinforcement is scalable. Scalable meaning that you can have a different shape of the product, whether it is hexagonal or in the shape of honeycomb, or it can be in rectangular or square shapes. So it is very flexible, can be transported and folded, and has a small volume. It can be stretched into a net during constructions and filled with materials such as soil, gravel, and concrete to form a structural body with a high strength lateral binding and high rigidity. And this is very strong bearing capacity, higher lateral binding and anti-skid, anti-change shape, and enhance the bearing capacity of the road bed. The next one is using the soil improvement. Other than example for soil improvements, using the cement or lime as a chemical stabilization, and then you can use thermal stabilizations. You also can have the biostabilization. The last one is natural and electro-osmosis. So the electro-osmosis is very, I think, the uncommon scene for the soil stabilizations or the soil improvement. Commonly been done by using the chemical stabilizations, and nowadays they are using the natural ways as stabilizations. So as you see here, there's a process where we apply lime or cement on top of the slope face, because on the top of the slope up here, while we spray the concrete and lime, one of it to increase the strength of the soil, and then we try to prevent soil from movement or retain it and provide infiltrations water to flow in, to seep in. And then the last part of the slope protections and maintenance by using the vegetations. Why we are using this one? Because we try to protect from erosions, we allow for water to flow out, and it provide to some kinds of reinforcement, and then lastly is the aesthetic value. So look at to this one, and after you have changed the slope geometry, the next one is maybe you reinforce the slope using the geogrid or the geomembrane. And the last not least, before you apply vegetation, you can see that in between the geomembrane here, there's a fill material inside it. And lastly, we close the slope face using the vegetation. So you couldn't see that beyond that once what was been taken or been done by the contractor to maintain the slope from any failure. So I'd like to share with you some kinds of the video that I have searched from is okay, wait a second. Okay, let me share to you one example from the this side. I'm sorry if you could not hear this one, but I want to show how the process has been done before and after. So this is the landslide occurred in the area of the road. Okay, see, uh, the road seems like do not have any failure due to the landslides. Okay, the next one will be on the last summary of the video.
My name is Mashita, and today I would like to share about slope protection and maintenance based on my understanding. The importance of slope protection and maintenance are the slope protection and reinforcement need to have an optimum strength during construction to ensure engineering quality and rate of process. Besides, Slope protection need to be adjusted and not cancel or decrease the engineering, geology and construction material, engineering types or comprehensive measure to ensure stability of highway subgrade. Furthermore, slope protection doesn't consider lateral pressure of slope stratum so that it should have enough stability. Next, rock slope or lower slope with silt, fine sand are easy to be weathered, especially under poor climate and hydrological condition, so it should be protected in time after earth and rock construction. Other than that is core protection. It happens at section of small water flow rate or weak flow destructive effect, paving stone, pannier and precast slab. So, it protects subgrade side slope along the river. Lastly, for high and steep protective structure, safety facilities should set to check and maintain when design and construction. Next is load failure repair option. First is unloading or changing geometry. We can use an excavation method. The second one is improving drainage. It is to minimize hydrostatic pressure build-up in the slope. It has two types of improving drainage that are surface and subsurface. The third one is slope reinforcement. It has two types that are geotextile and geogrid. The first one is shotcrete. We use mortar or concrete that pneumatically injected at high velocities over a grid of rebars. The next one is terracing or benching. It making slope more manageable by dividing it by retaining walls or friction pile. Other than that is rock bolts. It connects the fractured and weak surface to the stronger rock layers underneath for slope stability. Next is friction piles. It is the piles that are driven into the ground towards load-bearing strata. Next, vegetation. There are four types of vegetation such as erosion protection. Next, soil improvement. There are 5 ways to improve the soil. First, chemical stabilization such as using cement and lime. Second, thermal stabilization. Third, biostabilization. Fourth, natural or byproduct waste stabilization. And last one, electroosmosis. Next, sheet piling. It is the process of overlapping sheet piles driven into the ground to act as retaining walls. Next, structural stabilization. There are 5 types of it. For example, retaining wall. It is the wall that are designed to hold a substantial amount of soil behind it in place, and it is very expensive. And the last one, buttressing. It happens when we over-excavate the cut slope. That's all from me. Thank you.
Okay, I have no further discussion on this topic. Do you have any questions? So just now ends our class today summary on the importance of doing the slope maintenance and protections. Do you have any questions regarding on this topic or from the previous 2 weeks ago? Any questions? So I think that there's no questions. So the best for next Friday. And Assalamualaikum.
Salam. Thank you, madam.
Thank you, madam.
Madam.
Thank you, madam.
Thank you, madam.